morning, good afternoon, and good evening, everyone. My name is Erik Bush. I'm the CEO and co-founder of Demand-Driven Technologies. I'm delighted to be presenting you our webinar today. We're going to focus on building supply chain agility in the food and beverage industry, a favorite space of mine through the relationship we've got with Coca-Cola Beverages of Africa and a number of other clients in that arena. Couple notes around the webinar basics, if you will. Everyone will be in listen-only mode. This allows us to ensure high audio quality for all attendees, but it doesn't mean we're not interested in your questions. So please use the question feature of your Zoom control panel to ask questions during the webinar, and we'll cover those before we conclude. We are recording today so that we can make the recording of the webinar available to registrants and attendees, and you'll be able to share that link with others in your team if you're interested. We'll also be sharing the presentation materials. We won't be sharing, any of the software with you today, but we will be sharing the presentation materials we're going to cover. F&B is an interesting space, and we'll start by talking a little bit about some of the just generic market realities about supply chain. I think it's very important to keep that context in mind whenever we get into a discussion around this. And we'll talk about the need for more agility and resilience. This is showing up all over the place in terms of supply chain topics and speakers and things of that nature. I was at the Gartner conference in Phoenix last fall, and they were very, very heavy on the notion of resilience and talking to clients and their audience about a shift in the mindset we all need to be embracing to help us build more flexibility into our business models, how we operate, and obviously into our supply chains. We're then going to take that and kind of personalize it down to the context of things we've seen in the food and beverage industry. It's a very, very interesting space. It's seen a lot of pressures and challenges as the providers in that market continue to try to evolve and innovate and create new products of interest to the market. And those have some product implications in terms of how it impacts their supply chain and the operational challenges that they need to address. We'll then do a little bit of demonstrating of some of the technique and concepts that we'll talk about in the presentation here before we wrap up, take Q&A, and then conclude. Many of you have seen this chart. If you've seen me present over the years, I've kind of got a bit of a fixation on this. This is a picture of U.S. manufacturers' inventory turnover rates in terms of a ratio of inventory to sales. And basically what it demonstrates is that despite massive amounts of investment in ERP systems and software and the like over that horizon, we've really not gained any ground. We should see an acceleration, have less inventory, and yet that's not in fact the case. And in fact, you can see over on the right-hand side there, a little bit of a blip when the COVID pandemic hit in the 20 timeframe. And so it's kind of a bit of a puzzling reality that companies put a lot of money into their software investments, made a lot of organizational effort to try to capitalize on those, and yet the core metrics that really are so foundational to supply chain performance have not seen improvements. And as well, there's all these other points of noise or challenge. We're dealing with inaccurate forecasts. In fact, Gartner is advising its clients to quit trying to make your forecast better because you're not going to get there. You've got to instead look at how you build more operational flexibility to deal with the fact that the future is somewhat unpredictable. Companies are talking about staffing and issues, both in terms of the production side of the house and operations, but also in planning, where many of the staff are turning over at a rather accelerated rate, staying on board for maybe a couple of years and then turning over, and that starts another cycle of, identifying resources to come in, getting them staffed or trained up and the like, and it's presenting some pretty intimidating operational challenges at that level. SKU proliferation is one we're going to talk about today. It has been rampant in the consumer goods space and especially in food and beverage. And we'll talk about some of the implications of that and how it creates more complexity for our clients in that environment. The result is we have a lot of firefighting. The systems aren't doing the job for us. We've got a lot of workarounds, and so it's kind of a very, very frustrating environment. And I think a lot of the foundational issues relate back to the concepts of material requirements planning. It's the backbone of all the supply chain solutions that are out there in the market. And MRP as a concept is quite basic and simple to understand. It says because we have all these things we need to do before we can sell an item to a customer. We need to go buy stuff, we need to go manufacture it, we need to package it, etc. We have to start with a forecast because we have to start the activities well in advance of that actual sale to ensure we have the stock available when the client asks for it. So what MRP does is takes your forecast and it backward schedules what you need to buy, then convert through manufacturing or assembly or whatever your process is, then package and distribute to meet that forecasted demand. And it all sounds so logical, like what else could you do, right? And yet it is based on a couple critical but flawed assumptions. The first of which is that demand is actually known, that we have an accurate forecast. And this has to be understood that it relates to both the time and quantity when the demand is needed and in what amount. But it has to be done at the item level because as consumers, we buy items. We don't buy categories. We don't go buy all the 6-pack, 2-liter offerings that a given provider has. We buy the flavors that we want. And so getting it in the pack sizes that we want. So getting it down to the item level is incredibly important. And if our forecasting efforts have been at kind of categories and the like, because we're trying to aggregate because we think better forecast accuracy, we also have to understand that implicit in that is this idea that many of the items will not be very accurate. And in fact, that's a core part of the challenge of MRP thinking in this environment. The other core assumption is that there's not going to be any variation. Everything we go buy is going to arrive on time and in the proper quantity and the proper quality. Everything we go to manufacture, all the work orders we generate will complete on time and in appropriate quantities. And everything we package and distribute will arrive on time out in our distribution centers to meet the actual needs. And we know that that's a false premise as well, that there will be variation. It's a fact of life. Murphy's Law exists and it's rather pervasive. And we've been taught some pretty important and rude lessons over the last few years with all the challenges that we face globally with the pandemic. So if those two assumptions are flawed, then obviously we have to think about things a bit differently, because can we really rely on prediction as a way to give us better results? Can we rely on prediction as a path through agility and resilience? My personal feeling here is that agility and resilience is all about being able to respond to whatever demand actually comes in. And when you think about that problem and you think that's the goal in mind, then we have to challenge the conventional assumptions we've been dealing with over the years, really the last 3 or 4 decades, where MRP as a predictive approach to supply chain planning has demonstrated itself to be ineffective in getting the right results. So, I went to the dictionary, Google, and looked up the definitions of agility and resilience, because I think it's important to just kind of get the essence of what are we after here. Agility is, defined as the marked ability to move with quick and easy grace. And when you think about it, it means that whatever comes up, you'll be able to respond and be able to provide, right? You've got that flexibility, you're Johnny on the spot, and you're able to respond with quick and easy grace to whatever circumstance you encounter. And resilience is more kind of the durability, we're able to withstand and recover from very, very difficult conditions. And the only way we're going to get there, quite honestly, is to become comfortable with this idea that the future is uncertain, right? So if we embrace the certainty of an uncertain future, we will start thinking about our business in a different way, and that path can lead to better improvements in performance in our supply chain. It's much like, in SpaceX, Elon Musk, he's a big advocate of first principle thinking, boil any problem down so there can be no underlying assumptions, and it will often open the door for an improved strategy. And in the space arena, if the prevailing assumption was we couldn't get rockets to land effectively on their tail, and therefore they all have to be expendable, and that drives the cost of space travel up so high, well, then once we figure out how to get the rockets to land on their tail and be reusable, now all of a sudden the game changes. And I think the shift from a forecast-driven concept to one driven by building agility is derived around challenging that assumption that we have to plan to the future. And I think that's where the demand-driven methods that we advocate for are so important. It's important to think about this too in the context of your industry. Now, we're going to talk about food and beverage, which are really oriented more towards a make-to-stock environment, right? Where you go to the grocery store, there's lots of bottles of Coca-Cola and Pepsi and the like on the shelves. It's ready for the consumers. You don't have to send an order in advance of going to the grocery store as to what you're going to select. So it's basically very well positioned for a pull kind of a concept where if we can pull to that rate of demand that's out there, we're largely going to achieve our agility by making sure we've got the right stock available at all times through material planning tactics. And that's where we would argue that developing a pull system based on true market consumption, utilizing concepts like demand-driven MRP as the foundation for doing that will put us in a much, much better spot. At the other end of the spectrum over here on the left is, heavy industrial environments, and I'll get my pointer going here, where, think about major engineer to order and products like that. In that environment, you're really going to build agility more through how well you utilize your production capabilities. How flexible are you in the way you deploy your production capacity to be able to deal with whatever comes in the door? It's not going to be so much around material planning. Yes, there may be some sourcing strategies you can implement to help bring in the specific items you need for a given MTO product that you're making. But it's a very, very different kind of arena than you're talking about when you're in the food and beverage space. And so food and beverage, other similar industries would be pharmaceuticals, where you are making the same products over and over and over again. Certain portions of the electronics business, not so much in consumer goods, but commercial electronics and other areas like that are real good fits in the make-to-stock strategy. And that would also include packaging solutions, which are very, very important part of the food and beverage ecosystem. So with that, then what are the tools that we can utilize to create this agility, and how can we then apply them to the F&B space? So we'll talk about material planning from the concept of what we call demand-driven MRP buffering. And the idea here is we want to develop a stock position that can ensure constant availability. If we know that we can have enough of the right material to meet whatever demand pattern comes our way, then we can allow ourselves to get the benefit of real consumption as the driving signal for our replenishment orders. Different than our forecast, right? It's really predicated on two major elements. What is the aggregate rate of demand that we need to be able to satisfy? And what is the level of variation we need to deal with? And the way demand-driven MRP buffers are set up, we start with the yellow zone. It's sized to cover usage over the lead time. So that's our replenishment cycle. And so if an item has a rate of usage of 100 units per day and a 10-day lead time, we would have 1,000 units in our yellow zone. We order at top of yellow, we're going to reorder and we'll reorder up to top of green. So everyone would say, well, that makes sense. You got coverage for the time that the replenishment order will take to arrive. That should cover us. But honestly, we know that demand may vary during that period. The supplier lead time or the work order lead time may vary in that period. So we need a way to protect ourselves to ensure this notion of constant availability, which is really foundational to what we're doing. And that's where our red zones have to be sized to address the actual item variation patterns we experience. And we'll talk about this a little bit further when we get into some F&B examples I'll share with you. If we size the red zone correctly, though, we can ensure constant availability. And if we're able to do that, we can pace to actual consumption in the market. So this, to me, is the corollary of the rocket landing on its tail. Once we change the assumption that we have to plan to the future, that there's a different way that we can ensure we have stock availability, then we can open our eyes to the opportunity of getting the value of a better signal, which is, to me, analogous to a lower cost of space travel by getting the rockets to be reusable, right? So red zone size to address variation, yellow zones covering our usage over the replenishment lead time. And then the green zones are going to be used to reflect our average order size or order frequency. And order frequency is going to be a key topic we'll talk about here because it can relate to our batch sizing, meaning that if we have heavy runners, we're going to probably want to replenish those buffers on a weekly basis. Slower runners, because there's setup costs involved and all those other factors, maybe we're going to set the order frequency in the green zone to be a bit larger to reflect a less frequent ordering pattern, because we know that if we have too frequent ordering, we're going to have too many setups and that'll impact our operational productivity as well. But brought together, these three dimensions really become a foundation through which we can now start to apply some really interesting concepts in our food and beverage arena. So let's talk about some of the things we've seen. And there's a white paper that we've published around food and beverage that I encourage you to take a look at and review because it helps illustrate some of these concepts in a bit more detail. We're going to talk about managing product proliferation, and we're going to talk about inaccurate forecasts and demand variation. We're going to talk about product freshness because that is more and more one of the critical buying criteria in the markets is, whether it's beer or beverages or food products, people want fresh products. And so it's put more stress on the supply chain to ensure that the remaining shelf life of the items we're shipping out to the retail channel are adequate to meet their requirements and ensure the product's fresh for the consumption by the end user. And then obviously promotions and product introductions are other things that are kind of the way of life in the food and beverage space. So we'll give an example when we do the demos of how we can facilitate those through some of the tools in Intuiflow. So let's talk about product proliferation. I'm a big fan of Pareto curves. These are quite useful in looking at understanding business opportunities and where challenges may exist. This is drawn from a client of ours. It looks at make items. So these were end items that they were producing. And the cumulative daily usage value. So the daily rate of demand times the material cost gave us the value of this. And you can see something that is very typical in the F&B space, that a very small number of items make up the bulk of the revenue. Here we're about 12 items in, and we're at basically 90% of the revenue is coming from less than a third of the items, right? And the balance then, they're all contributing incremental revenue, but it's coming at a much slower pace. And this is kind of the long tail, if you will, out here to the right, where we've got products, we've differentiated, we have a lot of competition, so we're always innovating new products and offerings in the market. Some of those sell, some of them don't, and it becomes a challenge because I think food and beverage producers have to be very diligent about continuing to manage that product proliferation. This is going to generate further complexity, and we'll show you in a couple other illustrations here how it impacts your average inventory levels, how it's going to impact your batch sizing and your production schedules. And in fact, as we get further and further out to the right here, we're going to see more and more fluctuation and variation in the demand patterns. These are less predictable markets. These are steady, heavy runners over here on the left, much more variation being experienced over on the right side of the chart. So I'm sure this may be part of your scenario. Interested in any questions you have on this topic, but I think this is something that absolutely has to be top of mind from a supply chain. It's not just the operational aspects of your supply chain that are impacted, but it also gets into how do we innovate in the markets, where do we really try to dominate, and how do we keep control of the product proliferation so that it doesn't become a decrement to our profitability. Okay, let's talk about the impact this has then on variation and COV. This is a similar view, different data set of different items of cumulative daily usage value, contrasted with the coefficient of variation of the actual demand history, right? So you can see here on the left, very low COV scores. Coefficient of variation is the standard deviation of demand divided by the average. These are the blue dots. So the different items all have their spot on the graph using the right scale axis here, right? About a 1-to-1 standard deviation to average here at the lower left-hand corner. As we get further to the right, you'll notice that the curve is the regression curve here is increasing as we go further and further to the right, because as we get out to the slower movers, we start to see a much higher rate of variation in them. Now, you'll notice there's a couple outliers here in the kind of more the high runner end of it. And that may be because we were running promotional campaigns. It may be the nature of the consumption of that product has a different flavor to it. And so we have to be cognizant that the variation levels that we're experiencing here are going to influence our stocking levels. If we go back to this buffer example, those higher variation levels are going to mean we're going to have fatter red zones to cover that variation to ensure we're getting that constant availability that is so critical to being in an agile environment. As we look out over this, we see this is from a demand history view, but we also can see the variance from the standpoint of forecast to actual. So again, this is another item example from an F&B client where we looked at the variance of the item relative to the forecast, not forecasting, sorry for this typo there, forecast versus the actual demand, right? If the forecast is lower, then it is indicating that the forecast was lower than the actual demand and vice versa, right? And you can see we've got, I'm sorry, the other way around. It's the forecast, demand was exceeding the forecast, so that would cause these negative deflections. You can see a relatively high bias on this, but it's an indication that not only do we have actual consumption variation that we have to deal with, but we also see in living color that our forecasting, because it has to be time and volume dependent, is not really working for us. There's very few flat spots on this weekly view, and that's because of the fact that there has been quite a bit of demand variation over time. This was a fast moving item, high mover, so it still indicated a fair bit of that. When we look at some of the slow mover items, we saw a more wide dispersion between the highs and lows on the slower movers. So again, making sure that as we have this product proliferation, we understand that the more of those slow movers that we're dealing with in our portfolio, the more we're going to need to deal with that. And we'll take a quick look at our autopilot feature. We ran a webinar on this last month, but I'm just going to try to bring this home into the context of food and beverage, where we have seen that COV as a measurement of variation is not really equivalent. This is an example, 3 items with the exact same coefficient of variation score, where our red zone factor, our safety value, was dramatically different. Everything from 23% of a small fraction of our usage over the lead time in the example here on the right to 227%. And we've learned that it's the shape of the demand, the actual pattern of the demand is very critical to understand. We've also learned that lead time and the order sizing, in other words, the green zone sizing, has a big factor on our COV values. So our autopilot feature gives us a great tool to help you ensure that you're addressing that variation in a better way. And our demand planning tool also helps by measuring forecast value add and helps you gain control of the forecast error that is implicit in your forecasting activities. Another area of concern is product freshness. And this is, again, looking at a data set. I think we're using the same data set mentioned in the first example of around 40 items. And what we're looking at here is, again, our daily usage value. So our portfolio kind of displayed by where the daily usage value is, contrasted with what the average batch size was in terms of days of inventory supply, right? We would expect that the further to the right we go, the more we will want to be running larger batches of that item relative to its rate of usage, because we know that there's a setup involved. The more setups we do, the less profit we're going to make, because there's an expense involved with changing a line over for a different flavor, different pack size, things of that nature. So you want to see kind of a positive correlation of our average batch size with the trend line here, this regression line. You can see on the lower left, the high mover items were all set to very low batch sizes, so they're going to run more frequently. That is because of the nature of their products. Those that have less frequent less rate of demand because of batch size productivity need to have larger batch sizes. Some of these would imply maybe they're undersized. This one would be a great example where, hey, maybe we've overlooked, we didn't set the order cycle value on this correctly, so we're going to run it too frequently. Or we're not going to generate orders when we should, which might expose us to stock out exposures and things like that. When we're on the high side, the implication here is we're going to carry more inventory. And the reason for this is that, and I'm going to go back to our example again, in our buffer sizing, the way we can evaluate our average on-hand inventory is all of the red zone plus half the green zone. That's the formula we use, and it's a very reliable indicator of what our average inventories will be in a demand-driven MRP buffer. So the bigger my green zones get, the more my average inventory is going to go up. The bigger my variation is, the more my average inventory is going to go up. And so when we look at this chart, we want to make sure we understand that, hey, this is going to have an implication to us on the average inventories that we're holding. And I'll show you some illustrations of this when we get into the demonstration here shortly. And here you can see this. We looked at the actual inventory turnover rates, average days on hand as we've got further out to the right. You can see a couple outliers here. You would want to see a pretty tight correlation, and the good news is we're doing pretty well. On the high mover end, we're running at about 15 to 20 days average on hand, which if we're at 15, that implies that we're turning inventory at about 24 times a year, which is an excellent kind of turnover rate. When we get up into this range, we're going to be down into the single digits, which, in FMCG, bottling and things like that, that's probably not where you'd like to be. You should be able to turn at a higher rate of demand because you have the benefit of a bit more stability than you might be if you were in more of that engineered order, make to order environment. But we have to understand that those batch sizes and getting those correct has got a lot to do with how we set that up. So let's talk and do a little bit of a demonstration. I'm going to switch over to the software. I think we've got enough time to do this, and we're going to go over and look at Intuiflow here. And we're going to look first at the first topic we talked about was variation. So we created a platform called Autopilot. We did a webinar on this recently. The idea behind this was the following. If we can automate the settings of our safety factors in such a way that a user would be able to see that they're actually valid, that it's real, that it's not in a black box, but it's been tested against simulations of our actual demand history, and provide recommendations, not just for demand-driven MRP buffers, but also for min-max settings, because some clients prefer those, then we would be able to take a real critical part of that supply chaining environment and get it more automated, get people in a position where they can start to trust the system. So our autopilot is taking a look at demand histories, it's analyzing the part attributes, all of those demand pattern elements I highlighted in the PowerPoint, and then coming up with buffer recommendations. In this case, this is a bottler data set that we've built up and kind of validated. We're looking at a type of material, 6-pack, 2-liter items that are a core part of our product. You can see here that we've got 11 items in this cohort. This is one of our many pack sizes that we deal with. We have a current on-hand inventory of $3 million of inventory. Autopilot is suggesting we can get that down to $1 million of inventory, saving us $2 million. Some of the parts would be done through DDMRPs, others would take a min-max buffer setting, but between those two, we would hit our target service level of 100%. And we can look at these items by looking at the actual settings. And the solution will actually show us the autopilot simulations that would be required for this item. This happens to be the heaviest runner in the group. It's got a high rate of usage. You can see we analyzed and saw that targeting 100% service level, we're right at 0 in this little window here. We're going to see a better result if we adopted a min-max setting. We're going to get a little better performance through the min-max setting than the DDMRP setting. We can also see different service levels. We might not want to try to achieve 100% availability on all of our items. And so we can actually generate lower levels of service based on some base settings we feed the system In this case, we use 100, 95, and 90% service levels. And you can see the comparison of which of the inventory methods were going to give us a better result. And so the idea here is we want to attack that variation aspect. And this is an important part of what we're going to do to ensure that we've got the right stock settings. When we do this correctly, we're building agility into our business. We're basically saying we're not going to rely on that forecasted demand. We're going to ensure that the buffer has been set up to adequately service the market. We may utilize a forecasted rate of demand. And so we have the option of using, in this case, our forecasted rate of usage slightly below that of what our trailing rate of usage has been. So perhaps we're not exposed, but there may be times when the forecasted rate, because it's coming into peak season, there's promotional activities coming down the road, we may want to adopt a forward-looking rate of demand to size our buffers. So Autopilot is there in the platform. It generates recommendations for both min-max settings as well as buffered settings. It automates the journey. It makes it visual and visible for the user so that they can gain confidence in what they're trying to do. The second example we went through was related to the issue of batch sizing and factors like that. So to do that, we're going to go to our part simulation here. And we're going to play with a couple different scenarios. I'll bring up an item here and we'll look at its actual settings. We're going to take that same heavy runner we just looked at, and we're going to run a simulation against the forecasted demand that's been brought across into the system. And we brought in about 26 weeks of demand here. And we can see that, hey, we're actually going to get a very, very good service level. Actually, I'm going to have to change one thing here. Let me go back and rerun this on the full year basis. Sorry about that. Oh, I'm sorry, I can change that. No, here's where I got to do it. Sorry for this. Mouse control, mouse control. This will just take a second, but we'll be able to see kind of the full year view and you'll get the right results that we wanted to show you here. But what we're going to do is we're going to take our forecasted rate of demand. We're now going to test that those settings that we have in place for the item are going to be viable. And we'll be able to get a picture of that. And we can then test it with different parameters for our green zone sizing. Remember in the illustration, what we were trying to do is get a better view of how do we set up our batch sizes to ensure that we've got appropriate inventory carrying levels for our various items. Okay, we'll go back to the part simulation. My apologies again. So here we're going to see we're able to generate an average inventory value of $382,000 with 9,500 units. If I go to look at this item in the workbench, what's wrong with the system? You can see our buffer sizing here suggests that we are going to have, with 8,300 units on hand, an average of 15 days supply. That's taking all of red plus half of the green zone and dividing it by our rate of usage to determine what our effective days on hand value would be, right? So this buffer sizing is very, very core to what we're doing. And if we look back at this simulation, we're slightly higher than that, but you can see in our forecast, we've got increased rates of demand as we get towards our peak season, which is inflating some of those inventory numbers. Now, if we wanted to, we could change our order cycle. This is how we control the size of that green zone. It's using an order cycle value in this case. And let's say we go to the other end of the extreme and we put a 28-day value in. You're going to see that we're going to go from 95,000 units of average inventory to something much, much larger. And you'll see that the green zone sizing is going to reflect that accordingly. So now our green zone is much larger. We had generated around 52 orders, I think it was in the previous example. We're now down to 14 production orders. Yeah, that may feel good because we're running bigger batches and we're not, but we're also going to hold a lot more inventory. We were going from 9,500 units average on hand to 159,000, about a 50–60% increase in inventory level. If we've got shelf life exposures, that's going to be a concern for us. So what we're trying to illustrate here is that we can utilize these different values as a way of getting an understanding of where to set our parameters. I think one of the great aspects of DDMRP, and we'll do a 14-day view here so you can see that as well. So now we've moderated the inventory a bit. We doubled the number of supply orders or production orders we would have generated from 14 to 28. We're getting onto that roughly every 2-week kind of cycle. 28 times 2 will be 56 weeks. So we're a little bit ahead of that. And that's because in the concentrated period of higher demand, we're triggering more supply orders to make up for that. And what this does allows us to come back to this picture and start sizing those order cycle values to ensure that our average batch sizes line up with something that makes sense based on the rate of usage. Clearly, we have to consider shelf life and other factors like that along the way, but this is a way that we can get kind of alignment between our stock buffer settings and how do we achieve those kind of operational benefits that we're looking for. We've talked about forecast accuracy and demand variation, and then the last example I wanted to do here was to look at promotional events. So let's go back into the software. And what we'll do is we'll go in and look at the demand planning module. And what we're going to do is look at that, the scenario of a promotional event. So in demand planning, we have the opportunity to look at items at the specific item level. So we can go through and look at all our 6-pack SKUs. This is the one we were just talking about, and see what its forecast looks like. In our forecast platform, we're monitoring the actual demand against what the generated forecast is. It's selecting from one of several hundred algorithms in terms of what is the best fit for the actual demand patterns, and then generating our weekly forecast going forward. We can then also see our items in aggregate. So we'll go to the Forecast Edition tab, which allows us to see the 6-pack 2 liters and what they represent in aggregate as we go out into the future. So here we're going to go over and look at our 6-pack 2 liter kit and our promotional tab. This is in our S&OP module. These are the demand values that we're looking out at over in time. We're going to evaluate making a change here in week of April 8th. I think it's week 15. And we're going to go ahead and make an adjustment. Let's say we're going to run a campaign for all 6-pack 2 liter SKUs. We think the aggregate volume is going to go up from 120,000 units to somewhere in the neighborhood of 300,000 units. So we'll go ahead and edit this value. I'm going to send that back to Intuiflow, and it'll digest that and allow us to see the impact of that on our SKUs. If we go back to the navigator and we look at that same group of SKUs, you'll see here that they're each getting their share of that adjustment. Instead of an expectation of 73,000 units in week 15, we're now talking about 183. And you can see this is a big spike of demand that's coming in that obviously we would expect is going to pose some inventory challenges for us. So we're going to go ahead. You can see now we've brought in that 300,000 units of demand here. We're going to go ahead and rerun the simulation to show that what is the impact of that to our items. And you'll see some of them are going to show some inventory exposures here. This will take just a minute or two to run, but it'll give you an idea of how do we deal with that, because my point here would be the following. Wherever we can, we want to be as demand driven, and that creates agility for us. But yes, there is absolutely cases in food and beverage and other industries where promotional campaigns, certain seasonal events, even the other side of it, those are incremental demand, where the other side would be where you've got shutdown periods and you're going to need to pre-build stock to cover a line changeover or a line maintenance. Factors like that are the reality of the world. When we look at our 2 liter items now, we'll see that a number of them are going to have pressure on their inventory. In fact, it's already filtered to this main item that we were looking at earlier. And you can see the impact of this promotional demand during that period, right? It's created a huge inventory gap that we obviously are going to need to address. And so the question becomes, how do we pre-build for campaigns? We can't make all the stock if the campaign is going to be that significant. Maybe some campaigns will not be so serious and we won't have to take corrective actions. Others will. Some items within the group may not really be impacted if we break this filter here. What we'll probably see is that some of the items are really not going to be as severely impacted. The ones down here, for example, probably had too much inventory to begin with. And while they're going to have an impact during that period, it's not nearly as severe to them as those that are at the top of the group here, depending on their current status and things of that nature. So what we'll do is we'll go back and run now what we call intelligent adjustments. And this is allowing the system to then say, okay, while we've got this promotional campaign, we know it's not going to affect all the items. Let the system generate the revised supply for us so that we can meet those requirements and actually pre-build the stock in an adequate time to ensure that. These adjustment factors are really going to change the shape of the buffer for a period of time, triggering early replenishment orders to allow us to ensure that the material is available prior to the event so that we're in a better and more prepared position. And when we get back here, we'll go back to that same stock item here on the inventory side. So here's the one we had looked at. And we'll look at the projection tab here. And you can see what has happened is that we've created a huge spike to cover the incremental volume. Up until then, we were running demand driven. During this period, we're pre-building for the promotion. And then immediately afterwards, we go back to the demand driven approach, right? So we don't need adjustments across the full year. There's just that one period that we have to worry about. And instead of having a user try to figure those adjustments out, we're allowing the system to do it for us. There may be a follow-on implication from a rough cut capacity planning. If we were to look at the production line that these items go on, which is line 1 in our demonstration data, you can see that, yeah, we're actually going to see some issues here. What we then do is run a constrained plan, constrained NPS plan to allow us to pull this demand further up. You can see we've got pockets of availability here in the earlier weeks. That gives us plenty of headroom to be able to deal with that in terms of the incremental production that we need to satisfy. There's other concepts around this, like rhythm wheel planning and things like that, that we would think are great fits for the F&B space. So let me go back here then to the presentation. We'll kind of wrap up and we'll see if we have questions. But that was just really trying to give you a quick view. Hope you're seeing the slides here. Kevin, can you confirm?
Yep.
Okay. I don't see the green bar around it, so I just was worried it wasn't coming across. But we covered, demand variation. We talked about product freshness around the batch sizing and tailoring our SKUs and our batch sizes to the rates of demand within your product portfolio, because those slow runners that inevitably show up in the F&B space are something you need to deal with. We can deal with forecast inaccuracies and demand variation. We also have tools in our demand planning module to allow you to improve forecast accuracy. And then promotional events, we showed you the illustration about how we can incorporate those through identifying them as a forecasted event, properly dealing with them in terms of understanding where they're going to create pressure on our stock positions and creating adjustments for that in the same light. As kind of a follow-up, there's a number of other dimensions to this story. We don't have enough time in the webinar today to kind of cover all the different aspects, but things I would want to leave with you to consider, and if you're interested, we'll be happy to have a follow-up discussion with you about this. One is the application of rhythm wheel, or what's called fixed schedule variable volume production planning concepts. And the idea is that you create a rhythm wheel, like for our heavy running SKUs on that 6-pack, 2-liter bottling line. How do we arrange our green zone sizes to fit within a rhythm wheel so that they come up for replenishment on the appropriate frequency while also creating a sequence, because inevitably in food and beverage, there's flavor sequences, allergen sequences, things like that that you need to deal with to improve on your setup time and changeover times and things like that. Rhythm Wheel is a great example. We're starting up a project on this front with one of our clients, which we think is going to help really bring the manufacturing or the production side of the house together with the supply chain planning side and get everybody on the same page. There's implications on S&OP. S&OP, I think, is an opportunity to do and really kind of rethink the paradigms that have been so prevalent. Just like MRP is based on prediction, S&OP today is practically taught and practiced out in the market. It assumes that we're all going to get together on a consensus demand plan, which will then generate a consensus supply chain plan, all predicated on a forecast that we know is frankly going to be inaccurate. And so our planning is really not allowing us to build the agility that we think we should be able to create. And so we've talked and done webinars on building an S&OP process that creates more agility in your business. And hopefully you're seeing how some of those concepts can come to light here today. Enabling automation in planning. The more we can get users to trust the system because we've properly addressed variation, because we've done it in a visual and user-friendly way, the more we can bring automation to bear and help alleviate some of those challenges, staffing challenges, especially where people have too many things to work on, not enough time, more and more SKUs and less planners out there means it's just that much more difficult for them to do their job. And if we can enable more automated planning, we can get to a better spot. And then in the side of distribution, that's a big part of a lot of the F&B clients that we've worked with, being able to effectively distribute product out to the market without a lot of forecast dependency, using what's called prioritized share distribution in our distribution module works extremely well. It makes the job far easier. You're replenishing based in kind of in a Kanban fashion to the stocking levels you've set and desired out for your forward depots and forward locations, giving you the right kind of value as you go through. So with that, I'm going to stop the webinar and or stop presenting and see if there's any questions from any of you all.
We do have a couple of questions, Eric. The first one is, we are a contract manufacturer of food product items. How can we utilize DDMRP and Intuiflow to address our needs?
Great question. We've seen many clients in the F&B space going to some degree, maybe not on all, but on some products, more of a contract manufacturing basis. They're either buying capacity that they don't have internally, or they're buying capability in the sense of able to create products that they don't have in-house themselves. And so the leverage of contract manufacturers is pretty prevalent, not just in food and beverage, but in personal care products and household care and other categories like that that are very similar in nature. Yeah, I think if I were in the seat of a contract manufacturer, I'd look at this in a very positive way. In essence, I'm selling capacity to my customers, right? And I know that those customers are going to have issues with their own forecasting and the like. And I would look at how we can utilize these concepts as a way of creating a more concrete service level commitment to my customers. Meaning that if I do a proper job of buffering the materials, the packaging items, labels, you name it, things like that, so that I am more ready to deal with whatever variation my customer, the end customer, is dealing with in the market, then I stand to gain better ground. A lot of this is done with the big grocery chains, that have private label products, their own bakery, if you will, but they're actually utilizing, contracted services through other providers that do their own products as well. So I think there's a real path to create a competitive advantage for a contract manufacturer using these same concepts. And we'd be happy to meet with you and kind of talk through that in a bit more detail. But I think there's a great use case there for those in the contract space.
Thank you, Eric. Got another one for you. How can Intuiflow help us with pre-build of stock for peak season?
Kind of illustrated that, maybe that question came in ahead of time, but that's very much the story that we tried to illustrate with that demonstration here in the software of the stock buffer that we had in the item that had the promotional event. It's a very much the same kind of story here. We have the automated tools in the solution that allows you to build these compensating adjustments. You can see the buffers are getting larger on this item. That means it's got an increased rate of demand out in the future, maybe not in the near term, but as we go further out, it's going to accelerate again. So you can use forecasted rates of demand as part of how you size your buffers. And there's tools in the system to help you identify where those opportunities would exist. And then too, as we illustrated there, on the rough cut capacity planning, you can also utilize constrained planning in the RCCP model to help generate how soon do I need to pre-build. We've got some clients in the food space that are literally working 7 months in advance of the actual demand. In their product case, they have to do a lot of deep freezing of product ahead of time just because the agricultural market that services them doesn't have the bandwidth to provide that much incremental supply during those peak seasons. So there's great tools in place to help with that.
Okay, Erik, one more question for you. Can you share a bit more about the concepts of rhythm planning?
Yeah, so rhythm planning is, I kind of mentioned this briefly here, is this idea that you've got a sequence that you want to go through. And actually, I can show a little bit of it here. We would, let's close this guy out. And we'll let's go to the 2-liter items here, or the line 2 items in our demonstration data. The idea is that you want to set a sequence. So you can see here the order cycle overrides. These values indicate that these with the 28-day cycle are slower movers than those with 14 and 7. So the items with 7-day order cycle, we're assuming they're going to run pretty much on a weekly basis, right? Their green zone sizes have been sized accordingly. Those at the other end are the 28-day items. Those are going to be those that were on the right end of the Pareto curve that we showed. So in other words, we've got slower movers. So we would set up a sequence that we operate, and there will be a flavor sequence. And what we would be generating is orders each week. So here in this week, we have order recommendations for a couple 7-day items and a couple 28-day items. The others are not in need of replenishment. We can see here that we've got 103 hours of production established for the recommended orders for these 2 pack sizes, 12 packs and 24 packs, which both run on the same line. Again, a mix of heavy runners with some slower movers here. So what we would do is we would go ahead and let's say we have 120 hours of production. We would top this up to, and we'll put in 120 hours as a rough estimate. And it's going to generate adjusted volumes for the different SKUs, right? So what we're doing here is we're actually creating a better mix based on the fact that we do have some additional capacity. The idea is that we're trying to flatten our schedule. We're going to top up some buffers that otherwise wouldn't have gotten an order recommendation, because otherwise this, variance would have translated directly into the production schedule. Now we're going to do that. We're then going to take those orders and we're going to put them into the flavor sequence. So a rhythm wheel always has a sequence to it. It may be light to dark, or non-sweetened to sweetened, or whatever, depending on the different ingredients that you're utilizing in your clean outs and setups and the like. And that sequence would then allow you to set up a cycle that you're going to go through. Each week, we would do planning essentially once a week for what we're going to produce the following week. And that week would represent the 120 hours, basically 3 shifts of, 40-hour schedules, or, 3 shifts of 8-hour schedules on a 5-week basis, and allows you to do that in an organized way. The idea in Rhythm Wheel is that we want to stabilize production. We want to keep that stable. That helps with our staffing issues. It helps with managing the shop floor. But we also want to use our buffers to then determine what are we replenishing within that wheel each week. Some items may not require replenishment. We'll skip them in our sequence. In the case of what we were dealing with, we only had, I think, a handful of items in each of the pack sizes to deal with. And so this would automate some of that planning for us. Those buffers had been set up for this kind of configuration based on their order cycle values. Again, reflecting strong movers and slower movers per the Pareto distribution we were talking about earlier, and allowing everything to fit within the capacity that we've got. It's a pretty well-known concept. A lot of companies in the F&B space are using it to some degree. We think that the marriage of the DDMRP concepts and how we organize your stocking positions, coupled with the idea of rhythm wheel planning, is a great fit for planning in that environment. Any further questions?
That is all I got, Erik. Thank you very much.
Okay. Well, look, thanks everybody for your time and participation today. Apologize for a little snafu there on the one bit of the demo. Make sure will that go more elegantly in the future. But as we said, I think there's a great opportunity here to get tremendous value for you in food and beverage space. We've got the white paper. You can get access to that through the website or follow the link here. We also do simulations. And I think this has been really part of the success we've had, is that we are totally transparent with clients. So you have the opportunity to see in real color or living color, the way your items would behave utilizing some of these tactics. And I think it's a great way to take that first step towards understanding, would this be a fit for your environment and can you get value from it? It's amazing to see some of the observations that come out. We hear such unique stories and anecdotes that come away from those simulation reviews. We do it in the software using the autopilot tool, so you get exposure to that. And it will really give you a better sense of, is there a business case for you at that in your environment, which I'm confident it would do. But anyway, with that, we'll go ahead and adjourn the call. Thanks so much, everyone, for your time and participation today. And we wish you all the best. Take care now.
Yeah.